Okay, ladies and gentlemen, we're going to go over some hypothesis testing questions in the context of using the TI calculator this morning. And this is part of our homework. So, okay, let's go over the process here. So let's read question number 1. So 1 through 8 are hypothesis testing questions that have to do here with testing a proportion. Now, if you go through the instructions, they say identify the null hypothesis, the alternate hypothesis, the test statistic. We'll talk about the p-value in the future. We're going to use what's known as the classical or traditional method, and the conclusion about the conclusion about the null hypothesis and conclusion that addresses the original claim. So let me just cut straight to the chase, and we'll show you what is really going on with this. Remember, this is written by publishers, and publishers just, yikes, that's a whole other story. Okay. So, okay, let's read this, and it says, a manufacturer, for question number 1, considers his production process to be out of control when defects exceed 3%. So I'm going to notate that the defects exceed 3%. So this is when the manufacturer considers the process to be out of control. So I'm just going to kind of write that down here. Exceed means is greater than, and that's 3%. So I'm going to kind of just notate that information. Production process out of control. Defects are greater than 3%. Now, when you read further here for question number 1, it says a random sample. Okay, this is sample information. So you have a random sample has 85 items. That's sample size. And the defect rate is 5.9%. So that's a sample proportion, ladies and gentlemen. So I got to write it down somewhere here. I just maybe put it over here. Sample proportion is 5.9%. So that's the defect rate. But the manager's making this claim. Now there's a claim coming. Let's see. Okay, what is the manager saying? Let me change the color here. What the manager claims now is that no, this is just a sample fluctuation, and production is not really out of control. So production is not out of control. This is the claim now that the manager is making. So I'm going to write that down in purple. So we're going to have to think about this, ladies and gentlemen. Remember, production process is out of control when the defect rate is greater than 3%. They told us that here. So if that's not the case, we use the complement. This is what the manager is claiming. So here's the claim now, okay? That no, it is not really, or it's not out of control. And that's what's going on here. So here, this is extremely important. This is the claim that's being made. Okay, so just to kind of be clear, and then they're going to say alpha here, you got the level of significance is 1%, and they want you to use the 1% level of significance to test this claim. Now, somehow I'm going to have to copy all this information to my Scratch work. So I'm going to try this out. I'm going to try to copy. Let's go to the Scratch work here. So this is what I'm using. So this is going to be for question 1. Hopefully I get all those notes down here. Okay, well, I got some of them. Okay, well, let's kind of write some of this down here. Remember, we got the claim here being less than or equal to 3%. This is our claim. I believe sample information, right? They had a sample size. Well, we had a particular sample size. We'll double check, but we know the sample proportion for defects is 5.9%, which is 0.059. Okay, so we have that, and I think this was the 1% confidence level. So alpha was or is 1%, 0.01. I just wonder what the sample size is going to be. Okay, so I'm going to have to go back and get that in for sample size. So let's go back and do that kind of thing. All right, sample size, hypothesis testing, where are you at? That's your scratch work. 85. Remember that right in here. Sample size is 85. Okay. Scratch. All right. Now, let's start to go with this process here, the hypothesis testing process. Now, remember what I taught you guys here, okay? We're just going to go through what's going on here. H0, H1. We're going to do the setup. We're going to set up your hypothesis test. And remember, this is going to be a null hypothesis. So remember why this is a null hypothesis. It's a null hypothesis because it involves a condition of equality. Okay? And so the opposite of that statement is P is greater than 3%. Now, we should maybe use the decimal representation. All right, we'll just do it now. So here's our setup of our hypothesis. Okay, so this is what you guys want to do. You got your null hypothesis, you got your alternate hypothesis. They're logical opposites again. And then I'm going to say to you guys, remember this, you're going to have to look at the question here. You're going to look at the alternate hypothesis. It's pointing to the right. Your inequality sign is pointing to the right. That means you have a right tail, where 1%, the level of significance, is in this particular tail. Okay, we're going to need a critical value. This is the Z distribution again. So remember, this is the do not reject the null region. Over here, you're going to reject the null. Okay, and we're going to have to find a critical value using inverse norm. Now, some of you guys have the default calculators, the default TIs. I have a fancy, calculator for this. If you're going to use the default, remember, you need area to the left of the critical value. That's the default. And that's I'm going to put that down here for us for now, default. And that's 99% because alpha is 1%. So 1% is in the right tail. It's in the rejection region. The complement is 99%. So ladies and gentlemen, we're going to find the critical value now. So in order to do that, we're going to go to the TI, because remember, this is a TI presentation. And yeah. Okay, how do I guess that's how we do that here. All right, we're going to go to, let's think about this. Oh, it's second distribution, inverse norm. Now, 99% is in the left portion here. This is the Z distribution. For the mean is 0, the standard deviation is 1. Make sure those things are there. So this is the default, okay? So I want to remind people, if you have that, that's the default. And you're going to get 2.3. We're going to go out to the nearest hundredths, 2.33. So here's our critical value. Okay. And that's what we're going to need. We need that critical value. Now, going back to the calculator just to discuss this here, right? We could have also said second distribution, inverse norm. Those of you guys that have this, you say, I want to just put the level of significance in there. And that's a right tail, right? Look at the picture now. That's a right tail. So this is what some people are going to say. I want to just use this because I have the nicer version of the TI where the level of significance is in your right tail there. So, okay, if you do that, then you hit right tail and notice you should get the exact same answer. So you do. But some of you remember, I'm going to toggle and I'm going to go to the older version. Some of you have second distribution. Let's clear this out if we can. I guess we have to hit enter. Oh my. I guess I don't have that. Maybe plus. let's see what happens with this one. Second distribution, inverse norm. Is the plus version the default? Yeah, you have the plus version maybe, right? So notice you don't have that left, right, center information for inverse norm here. So that's what I mean. You use the left. That's your default. Mean is 0. Standard deviation is 1. We're going to paste that in now. And ladies and gentlemen, yes. But it looks like for me, I got to figure out a way that TI plus this older screen version, I got to figure out how to get rid of that stuff. Don't know. Nothing works. Anyway, odd. So I spoke to you guys about how to find critical values using both versions of the TI. Okay, so we got our decision rule, and that's great. So I'm going to get rid of this so it's not distracting us. This is the nice stuff we should see. We're looking at a hypothesis test. And then the last portion I want to talk about or mention to you comes from the next step, where the next step would be to take your sample formally. But I say don't really take a sample. Now, notice what they gave us. They gave us the sample size. But remember, this is a sample proportion, 5.9%. The TI requires you to have actually an X value. They want the number of successes. So you're going to have to use some algebra and multiply both sides by n. Remember the formula. This is n times the sample proportion. This is how you get the value of X. So in this problem, we're going to have to get that X value. That's 85 times 0.059 here. Okay. And we're going to approximate to the nearest whole number. So I'm going to put clear that out. 85 times 0.059, that's going to be approximately 5. Okay? So we're going to use that value for the TI calculator. So that's something that, sometimes pops up because they gave you the sample proportion instead. So when you bring up the TI now, notice what happens in your TI. We're good to go. Okay? So let's go to calculator. Okay, calculator, we're going to clear you out. Well, we're going to keep you. This is all the relevant information. We're going to go to stat test. Remember, we go to, now this is a 1 proportion z test. That's number 5. 1 proportion z test. So I'm going to start to maybe try to see if I can get this here for you so you can see. That's kind of interesting to me. Just on my end, how to navigate. Okay. 1 proportion z-test. Now, remember, we need that p0. And when you say, what is p0 again? Forgot. We have to get that p0 here. p0 is the hypothesis. The proportion. It's p for proportion. For the null hypothesis, remember there's an h0. That's the reference. They go, what's the p0 in h0? The p0 and h0, here's h0, here's my null hypothesis. This is the p0 they're talking about. It's 0.03. Okay, so I want to remind people this is how you get those values. That's 0.03. So this is the stuff that you put in your TI now. Okay, all of this information, as you guys see, goes in the TI. So 0.03, that 3%, we found X to be 5, and now we need a sample size of 85. So I'm going to put 85 in here. Now remember, what kind of test is this? Is this a two-tail test? Is it a right-tail test, or is it a left-tail test? I'm sorry. Go back. Two-tail test. Left tail, right tail. I got to get my coffee in me. I believe this was a right-tail test, right? Sure enough, it's a right tail. Okay, it's a right tail test. So we hit enter, and now we're good. Calculate that. Now remember what we're looking for. We're looking for that second value. That's our test statistic, 1.56 to the hundredths. So this will be Z. It's really approximately 1.56. That's our test statistic. Okay. Now remember how all of this works. Any test statistic to the left of 1.56, we do not reject the null. Any test statistic to the right of this 2.33, we reject the null. So keep with me with the logic here. Since Z is 1.56, that is right over here. That's between 0 and 2.33, maybe somewhere over here, right? 1.56, that's the test statistic. It's in the do not reject the null neighborhood. In that region, do not reject the null. So do not reject the null. So go back to the null and you say this to the null. Hey, null, I am not rejecting you. So if you do not reject that, remember, you're really accepting this, okay? And this process is very simple. Stop and think. You're not rejecting the null. You are accepting the null. Where is the claim? The claim happens to be, ladies and gentlemen, it happens to be what you have just accepted. And that's the point. So when you draw your conclusion, there's only two conclusions that you're going to say. Remember? You're going to either say the sample supports the claim or the sample does not support the claim. So I'm going to write the conclusion right here. The sample does what? Well, what did you do to the claim? Right? You accepted the claim here. See how it's circled? And it's in red? Since you accepted that claim, what the sample is saying is that the proportion is less than or equal to 3%. So since you're accepting your claim, the sample supports the claim. Okay, so your sample is going to support the claim here. Right? Let's go back. I think we're good. Sample supports the claim. Let's go back and look at this sheet here for number 1. Right? Remember what our claim was. The claim is that, you know, it's under the 3%. So H naught, they get lazy. They have, that's where it's equal. Well, okay, I think yes. H1, yes, is what we have here. This is really less than or equal, ladies and gentlemen. Even they say, hey, that's where it's equal. They just got lazy with putting that there, okay? So let me go back here and say this was the less than or equal. Okay. H0 and H1, I think this is what we had. Is that true? Less than or equal? Yes. Greater? Okay. So far, so good. Where are you? Okay. There is a slight, because remember back in the day they used tables. They didn't use the TI, so the tables were less accurate. So if you got a test statistic here that was 1.56, slightly off, that's fine. Only because they use tables and we're using a more accurate TI, doesn't use tables. Okay. What else? Critical value by the TI. That's still good, or critical value. And notice what they're saying. Fail to reject the null hypothesis. There is not sufficient evidence to warrant rejection of the manager's claim that the production is not really out of control. Okay. Well, what does this mean? There is not sufficient evidence to warrant rejection of the manager's claim that production is out of control. So let's go back and we're going to discuss what we have here in our situation here. Let's look at this here, right? to make a long story short here, this is why Mr. Judge is going through this with you. Remember, the manager is making this particular claim here. Right? I guess I'll go here. The manager is claiming that it's less than 3%. Let's go back. Right? So production here is out of control when it's greater than 3%. And the manager is saying, hey, you know what? This is not really out of control. So the claim is that it's under, less than, or equal to that 3%. So what our hypothesis test is suggesting here, when we look at that, is that this statement that it's less than or equal to 3% based on the sample is what you should conclude. So the sample supports what the manager is saying. The sample supports what the manager is claiming, that it's less than or equal to 3%, and that it's not really out of control, because being out of control is when this proportion is bigger than 3%. So I would prefer to keep it very simple here, ladies and gentlemen, just as I've demonstrated in my lectures to you guys here, right? That what this really means when it comes down to it is everything I'm showing you here. The sample is supporting this claim. The claim happens to be that the true proportion is less than or equal to 3%. End of story. So what I'm expecting for you on the test is exactly this, but what they're saying in the solutions is pretty much summarizing things as well. So it's just another way of phrasing it, and that's fine too. But it looks like we got number one out of the way. So good. Good. Okay. So I'm glad we're going over this morning, just in case you're pulling your hair out. Okay? Now, I'm going to do the odds. I'm going to leave the evens for you. So I'm going to go now to number 3 here, ladies and gentlemen. Number 3 here. Okay? So let's read number 3. Let's go through this now. It says, according to a recent poll, now a poll is a survey. So you're getting sample information right in there. And they're saying 53% of Americans would vote for an incumbent president. So this is a sample. Oh, okay. I apologize. It is a poll. It comes from a sample. Now, what they're saying on this here, if a random sample of 100 people, now this is another sample. So you get a random sample of 100 people. That's another sample. This is your sample proportion. So it looks like, okay, you have a poll, and then which is a sample. Then they did another one. Okay. And I'll put this next to it. Okay. 45%. That's the sample proportion. Okay. So let me actually write it down, because you know what we're going to do. We're going to copy it. So there's a second survey, a second poll, and this is the information. Okay. All right. So if a random sample of 100 people results in 45%, who would vote for the incumbent? Test the claim. Okay, here's the claim now. Here's the claim coming. Test the claim. What's the claim? That the actual percentage, that's the actual percentage, that's the true proportion. P is, have the word is, 53%. Okay? And again, now they want us to use the what? Again, use the 1% level of significance to test that particular claim. So this is what's going on. I know you're saying, okay, according to a recent poll, 53% would vote for an incumbent president. All right, I guess that's another way of titling this statement here, right? Okay, you guys see what we're saying? I guess they're titling it. So I'm reading through this, and this is what's going through my mind, okay? And alpha, again, this is going to be the 1%. So I'm going to copy all of this again here. Okay, so we don't have to take it with us. This is the information for number 3. Let's go to Scratch. And number 3 here, this is what's going on now. All right, so let's put this together here, okay? I got my null hypothesis. I have my alternate hypothesis. Now remember, this was the claim that 53% were going to vote for the incumbent. Okay? Now, since it involves a condition of equality, this is a null hypothesis. All right. So remember, we need the logical opposite. Either P equals 53% or P does not equal 53%. This is setting up your hypothesis. Now we're really testing the claim, ladies and gentlemen. So you guys know. And alpha was, yes, again, 1%. It's the 1%. Oh, I apologize. 10%. This is alpha, right in here. 10% level of significance. All right. Okay, alpha's 10%. So anyway, good. That's our level of significance. Now, let's actually draw our bell. Let's get out the normal distribution. And let's remember this process. This is a Z distribution again. And, you know, my bell doesn't look so symmetric and pretty. So let me try to do it again. It doesn't look as pretty as it was before, but it doesn't matter. Okay. H1, you always look at the alternate hypothesis. Since it's not equal, this is a two-tailed test. Not equal. Do not reject the null, and over here you reject the null. Okay? Alpha's 10%. So that means 5% is in the right tail and 5% is in the left tail here. So this is my alpha. We need critical values here, ladies and gentlemen, and that's where we're going to use the inverse norm. So we're going to do it two ways again. Let's assume you have the, let's see what we get, second distribution. I think this is the latest and greatest TI. No, it wasn't. Let me switch my calculator, though, to the latest and greatest. There we go. Second distribution, latest and greatest, inverse norm. And you go, okay, what's in the center? Because I'm going to use the center here, right? So 10% level of significance. Alpha is 10%. It's the sum of the tails here. That means 90% is in the center. So when I use the latest and greatest, I'm going to put 0.90. Mean is 0. Standard deviation is 1. We have to now go to the center because that's where we're telling the area is 90% in the center. We're telling the TI that. 90% in the center. And ladies and gentlemen, we get two critical values. And we should because it's a two-tailed test. It is 1.645 and it is minus 1.645. These are the two critical values you guys are looking for. This is what we need. The two critical values. Now, assume you have the default. Assume your calculator is not, you know, the latest and greatest. So you're going to use area to the left of that critical value. This is the default again. Area to the left. So notice what you do now. Let me change. I change. Now, see this? For the inverse norm, area to the left is 5%. Because alpha's 10%. That means 5% is in each tail because there's two tails now. So notice what you get. You get that one Z value, area to the left of a negative 1.645, and that verifies exactly what we got using the latest and greatest TI, ladies and gentlemen. So just going through those details here with you guys here, okay? Using your TI now. Anyway. So either way, we're good. Let's clean this up. Now remember what we need. The next step would be to take a sample. So I'm going to copy this here. I know it's kind of small. Sample size, remember, was 100 in this example. And I believe it's what was the sample proportion? 45%? So notice again, they gave us the sample proportion, which is fine, 45%. But we need the X value if we're going to use the TI. So X will be N times the sample proportion. We're going to approximate to the nearest whole number. So 100 times 0.45, I don't need to use a calculator. I know that means X is 45, okay? You can double check. And then we need P naught. And you say, what in the world is P naught? Well, let's change this 53% to 0.53. That's your P naught. Let's change this to 0.53 just to be consistent with the decimal representation. But the P naught, that's the proportion in the null hypothesis. This is what they want you to use in your calculator. Okay, so we need P naught as well, and that's 0.53. Okay, we're now good. We're good to use our TI calculator with this information. All right. Okay, so we go to stat, test, one proportion z-test. And you go, all right, P naught, 0.53, 0.53. The successes we have is 45, and the sample size was 100. Now remember, this was a two-tailed test. This was a two-tailed test. Double check. Two tails. Okay, good. Two tails. Nice. So put that not equal for two tails and hit calculate. So remember your z-value now. Z-value here is negative 1.60. That's the test statistic. Approximated to the nearest. Let's do the nearest thousandths, and I'm going to tell you guys why. This is 0.603 now. You say, hey, why did you do hundreds? Why did you do thousands now? Because remember your critical values. You're trying to compare where that number, that test statistic lives in your decision rule, and your critical values are to the nearest thousandths. So use a test statistic value also to the nearest thousandths right here. Now remember how this works. Any critical values between a negative 1.645 and a positive 1.645, we do not reject the null. Any value that's bigger than that critical value of 1.645, you reject the null. Any test statistic that's smaller than the negative 1.645 critical value, you reject the null. So you notice that negative 1.603 is a little bit to the left over here. This is why you use the same place values, okay? So because when you try to see where it lives on your decision rule, that's going to be very important here now, right? So there's where that negative 1.6, it's not past the negative 1.645. You got negative 1, think of it as 603 and 645. It would be to the left there. It's in the do not reject the null neighborhood. So, ladies and gentlemen, we're not rejecting the null here. Okay? So, go back and you say, I'm going to look for the null. It's right in here. I'm going to say, guess what, null? We're not rejecting you. Okay? This is where the null is. We're not rejecting it. We're going to accept it. And I'm going to put a circle around it. Do not reject. You are accepting. We're going to keep life simple. What are you accepting? You happen to be accepting the claim, ladies and gentlemen. So since you're accepting the claim, the sample supports the claim, ladies and gentlemen. This is your conclusion. By not rejecting the null just happens to be the claim. So that means this sample supports what's being said, that the true proportion here is 53%. So this sample is supporting that the true proportion will be 53%. Okay, and this is what this means. And let's go back and see what their solution is here. So we can talk about it and, laugh at what they're saying. No, not really. So notice this. This is, the null hypothesis is 0.53. The null alternate's not. This is the test statistic. We were just more accurate. Critical values, yes, were plus and minus 1.645. Okay. Failed to reject the null. Failing to reject is another way of saying accept. If he failed to reject, and it was the null, there is not evidence to warrant rejection. There is not sufficient evidence to warrant rejection of the claim. Yeah. The actual percentage is, 53%. So, yeah, they're pretty much saying the same exact thing that I just told you guys here. And we're good with that one. Let's go back. They're essentially saying what I just said to you guys. Okay? But what I'm looking here for is simply saying the sample supports the claim here. We're going to keep it simple, ladies and gentlemen. Again, those publishers wrote this. And, what happens in education, like what happens everywhere, I guess, maybe is sometimes they hire relatives to draw, to work on things. Very common, very common. So, ladies and gentlemen, there you go. This is all the information that we're doing, and I hope you enjoyed number 3. Okay, let's get rid of this. That leaves us to number 5. Oh, I'll get rid of that. Leaves us to number 5 here. Okay, so I hope you're enjoying this here in a nice morning for us. Number 5. Now let's kind of read through it all, right? Not start to jump to try to do some work on this. Number 5, okay. It says, an article in a journal reports that 34% of American fathers take no responsibility for childcare. Yikes. A researcher claims, okay, what is the claim going to be? Here's the claim. That the figure is higher for fathers in the town of Littleton. Yikes, what are they saying? The figure is higher. Higher than what? Higher than 34%. So here's the claim, ladies and gentlemen, that the proportion is greater than 34%. That's the claim. All right, so I just want to let you guys know there's the claim for 34%. It's greater. So they're saying it's higher there in the town of Littleton. All right. Now let's go further. Random sample of 234. Sample size. Says, yielded 96% who did not help with childcare. So that's not a percent, ladies and gentlemen. That's successes. So finally, we get a sample where N is 234, X is 96. So this is what they're giving us here. Okay? Who did not help with childcare. Test the claim at the 5% level. So we're going to test the claim at the 5%. Alpha is 5%. All right. So it looks like we got all the information we need. Of course, we're going to copy this stuff. I'm going to try to copy it. It's number 5. All right, let's write all this stuff down here. H naught, H1. So where does that null hypothesis belong? Notice where it goes. This does not involve a condition of equality, so it's an alternate hypothesis. And I'm going to change 34% here. 0.34, okay? So remember, the logical opposite is going to be less than or equal to 0.34. Okay, logical opposite. Let's move number 5 down. Okay? So there we go. All right, now, decision rule time. Let's draw our bow. Let's draw the z distribution. So now we have this z distribution here. Here's my 0. What do we look at? Remember this? This is a right tail. And we know 5% goes in there. And this is the do not reject the null. And I'll put it here, reject the null. Okay, so we need now critical values. And actually only one critical value. We need that threshold value. Okay, so what calculator do we have now? So if we go to the TI now, we say, okay, TI, I'm going to clear that out. Second distribution, inverse norm. 5% by the fancy calculator. Oh, no. Let's clear that out. Let's go back up here. 0.05 by the fancy calculator. Mean is 0. Standard deviation is 1. It's the z distribution. 5% is in the right tail, ladies and gentlemen. It's a right tail test. Fancy calculator gives us this positive 1.645 critical value. Okay, to the nearest thousands here. So this is what I wrote down here for my critical value. Okay, so I have that number. Now, go back up here and say, okay, what if I'm using the area to the left? What if I have to use the default here? Okay, default area. Well, remember now, if you're going to use the default area to the left of that number, the complement of 5% is 95%. So 95%. So go over here. Second distribution, inverse norm. 95%, ladies and gentlemen. We're going to paste this. And again, you see 1.645 there. All right. So ladies and gentlemen, either way would be fine. Using the default or not. And, you know, I've done it both for you here. All right. Okay. Pretty good. Now, what comes next, ladies and gentlemen? Sample information. Here's my sample information. Okay. You go out and you take your sample. There it is. We need P naught. This is our P naught. 34%. Here's P naught. So we're going to say P naught is 34%. 0.34. All right, you guys okay with that? 34%. P naught here. Fantastic. P naught, 34%. So let's go use that TI here and try to see what's going on. Let's get out the TI. And okay. Second distribution. I'm sorry. It's going to be stat test 1 proportion z test. So the sample proportion here is 0.34. X here is 96. The sample size is 234. Again, now P naught, we got to understand, is this a right tail test, a left tail, two tail test? I got to go back. It's pointing to the right. That means we have a right tail test. Let's point to the right. Hit enter. We're going to calculate. And let me double check, ladies and gentlemen. Stat test. I want to double check. I forgot to double check. One proportion z-test. So P naught 30.34, 96, 234. Looks like we're good. Apologize. Double checking. Okay. Test statistics going to be now z. We're going to go to the same place value of our critical value, which is the thousands. So our test statistic is 2.26, not 8, but 9, approximated to the thousands here. So here is what we were looking for. Here's your test statistic. Now, okay, we have to see where this number lives. So any value, test statistic value to the left of the critical value, smaller, we do not reject the null. Any test statistic value to the right of the critical value, you reject the null. So this is 2.269. So your test statistic is to the right of the critical value because it's larger than that 1.645 here. Okay? This is what we're looking at. Right? Okay, so it's in the reject the null region. Now, when you reject, ladies and gentlemen, you are rejecting the null. It told you to reject the null. When you reject the null, you're accepting the alternate. Okay? So reject the null because your test statistic is in the rejection of the null neighborhood. You rejected the null. Goodbye, null. You're no longer here. So when you reject the null, you accepting the alternate because you threw out the null, but you're keeping the alternate. You happen to be keeping. You happen to be accepting. You happen to be keeping. You happen to be accepting the claim. So that means the sample supports the claim because your test statistic reveals that the true proportion is bigger than 34%. Because that's what the alternate is saying. You threw out the null. Throwing out the null means you keep the alternate. So the sample supports the claim that the proportion is bigger than 34%. So those are those fathers who don't, that's greater than 34%. Those fathers in that little town. So let's actually see what this solution says for us, right? Let's go back and look at the solutions here. Fathers in little town. Number 5. Looks like we're okay for the null. Looks like we're okay for the alternate. Our test statistic was 2.2. Well, they gave it to the nearest hundredths. Alrighty. Our critical value was accurate. And you rejecting the null. That means throw out the null. There is sufficient evidence to support the claim. So, okay. And that the proportion of fathers in Littleton, is higher than 34. Okay. It's exactly what we said, just so you guys know. Okay, pretty good. Exactly our conclusions. So anyway, it's not too bad, ladies and gentlemen, not too bad. Let's see about number 7, all right? Number 7 on that homework sheet. Here we go. Let's see what this says. In a clinical study of an allergy drug, you guys can see that one, number 7. In a clinical study of an allergy drug, 108 of the 202 subjects reported experiencing significant relief from their symptoms. Okay, so, all right, a study, ladies and gentlemen, is a sample, and they're testing an allergy drug. That's fantastic. If you have allergies, you say, oh my God, let there be some great drugs out there for them. And they are. This comes from a sample. So they had 108 successes out of the 202 people. Okay, they have relief. Use the 1% level of significance. At the 1% significance level, same thing. Test the claim that more than half of all those using the drug experience relief. More than half. The proportion is greater than 50%. This is our claim. You say, why? Half is 0.5. 1/2 is 0.5, which is the same as 50%. So, remember this. 1/2, that fraction, is 0.5 as a decimal. They're equal, and that's the same as 50%. So this is what they're saying. Okay, that's the 1/2 portion, and more than is greater than. Okay, and this is for number 7. So ladies and gentlemen, we've got all kinds of good information here for number 7 here. All right, copy that. Let's go to our scratch. So for number 7 now, I'm going to clean this up. All right, so here we go. So let's kind of put this all together now. Remember, we're going to set up our hypothesis, H0, H1. So where does this go? You know where this goes? It does not have a condition of equality. It's an alternate hypothesis. And I'm going to change this decimal now. The logical opposite is the proportion is greater than or equal to 0.5. Okay? Critical value. And, okay, here's my point. Let me remind you guys, you got the alternate hypothesis telling us that this is a right tail. Now, I don't remember the level of significance. I didn't write it down. So I got to go back. What's the level of significance here? For number 7, 1%. It's right in here. It's 1%. Okay, so here you do not reject the null, and over here you reject the null. So we need the critical value again, ladies and gentlemen, and it depends on, and this is alpha's 1%, it depends on your calculator, right? So let's go back and think about this. Let's go to the calculator here now. I'm going to clear this out, and let's do the latest and greatest first, like we've been doing, and clear that out too. We're going to go to inverse norm. 1%, that's 0, 1. Mu is 0, sigma is 1. This is a z distribution, and we are in the right tail. All right. Hit enter. 2.33. That's to the nearest hundredths. This is our critical value. All right. Now, let's go to the TI here, right, where this is our critical value, 2.33. Let's use the default. Now, remember the default here, area to the left of the critical value. So if 1% is in the right tail, to the left of the right tail is the complement. This is 99%. using the default in case you have the default version. Second distribution, inverse norm. This is 99%. Now notice this, ladies and gentlemen. The default gave us the same exact answer. It's the 2.33 critical value. All right. All right. Okay. So next, we would try to go out and take a sample. Formally in our process. And you go, they gave us sample information. It's right in here. And we'll say, okay, they sure did. But we need the P0 value, the hypothesis and the null, the proportion in the null hypothesis, right here. This is that P0 of being 0.5. That was that 50%. Here we go. TI. So let's go to the TI now, ladies and gentlemen. We go stat test 1 proportion z test. Now 0.5, what is x? 108, what is n? 202. Is this a right tail test, two tail, left tail? This is a right tail. So here we go here. This is a right tail. Now we're going to hit calculate. What is your z value here? Your test statistic out to the 100th position, right, is 0.99. So this is a test statistic. We're going to call that a z value, 0.99 here, ladies and gentlemen, the iPad. Alrighty. Any test statistic to the left of this value, you do not reject the null. Any test statistic to the right, you reject the null. And we forgot to put the statement, so we're going to put it now. Oh, we did put it. It's down here. It's down here. Okay. Now, a test statistic of 0.99, where does that go? That's not quite 2.33. So there's your test statistic right in here. Okay, here's that test statistic. It's test statistic. It is in the do not reject the null region. So let's go back and look at the hypothesis here. Do not reject. Do not reject the null. So I'm going to highlight this. Here's my null. We don't reject it. And it draws a polygon. It doesn't draw that ellipse. So do not reject. If you're not rejecting the null, you are accepting the null. So you're accepting the null. You're not rejecting it. You are accepting it. What does that mean about the alternate? It's gone because you're accepting the null. You're not rejecting it. The alternate goes away. You only have one that you can accept. And you're not accepting the alternate. You're accepting the null. You are not accepting the claim, ladies and gentlemen, because the alternate happens to be the claim. We wrote that down. So the sample proportion is suggesting that the true proportion is greater than 50%. Uh-oh. This is less than or equal. Sorry. Oops. Go back. I noticed something here. Claim is greater, so that's less than or equal. Less than or equal. Okay. Sorry. I wrote it down wrong. But nevertheless, our conclusion is the same. Here's what I'm saying here. The sample is suggesting that the true proportion is less than or equal to 50%. Not greater than. It's less than or equal. Okay? Not greater than. It's less than or equal. So the moral of the story here is this. Because your test statistic lives in the do not reject the null neighborhood. You're accepting the null. The claim was the alternate. Throw that out. Final conclusion. The sample does not support the claim. Sample does not support the claim, ladies and gentlemen. All right, that's number 7. Now, let's see what the solution says here for number 7 now. See if we have the same kinds of things. So number 7, okay. The null hypothesis and then the alternate that's greater than 50%. Yeah, but remember, they got lazy with the symbol. They should put less than or equal. Because they have the equal there, they just put that as an equal. Just getting lazy. The test statistic is 0.99 to the hundredths. We have 0.985, right? So yes, to the hundredths, it's the same value. Critical value we had was 2.33, I believe. I think that was the same for the one we just did, 2.33. Let's double check. Sure was. Test statistic, 0.99. We have it to the hundredths. I apologize. We do have it to the hundredths. So far, so good. Fail to reject the null. Yeah, we are fail to reject. We are accepting the null. We said that. And there is not sufficient evidence to support the claim. Right? That's like saying not sufficient evidence to support the claim. That's like saying sample does not support the claim. All right? Sample does not support the claim. So anyway, yeah, it looks like we're good to go, ladies and gentlemen, for number 7 as well. Looks like we have all that information too. So we did good today. Slight mistakes, but when you catch them, they're not really mistakes. All right. So anyway, this is the first installment of hypothesis testing here, ladies and gentlemen. And I was only going to do the odds for this. I want to leave the evens for you because this is how you learn. You learn by making mistakes. And so the rest is going to be up to you. You do have the answers there. It looks like it's pretty good. So thank you for your time this morning. And I hope you guys do well. Okay. Take care.